Venus is often called Earth's twin. Same size, same mass, same rocky surface. But the surface temperature is 465 degrees Celsius every single day. Hot enough to melt lead. Hot enough to crush a submarine with atmospheric pressure alone. And it rains sulfuric acid. Now imagine that twin is us, Earth, placed exactly where Venus sits, 108 million kilometers from the Sun. Before we continue, your question for today. If Earth replaced Venus, how long do you think humanity could survive on Earth at Venus's orbit? Drop your answer in the comments. New here? Subscribe now, because this is where we put Earth somewhere it was never meant to survive. Venus sits at 108 million kilometers from the Sun. Earth currently sits at 150 million. We're moving closer, but not dramatically. Venus receives about 1.9 times more solar energy than Earth. That doesn't sound catastrophic until you understand what Venus did with that extra energy. Venus triggered a runaway greenhouse effect. Billions of years ago, Venus may have had oceans, liquid water, maybe even life. But as solar energy increased, water vapor began evaporating. Water vapor is a greenhouse gas. More vapor meant more heat. More heat meant more evaporation. A feedback loop with no off switch. The oceans boiled away completely. Carbon dioxide, released from rocks by the heat, flooded the atmosphere. The atmosphere became 96% carbon dioxide, 90 times thicker than Earth's, and the temperature climbed past 200 degrees, past 300, past 400, until it settled at 465 degrees Celsius, where it has stayed for billions of years. Earth at Venus's position doesn't cook instantly, it cooks slowly. And that slow cooking is somehow more terrifying than a sudden end. In the first decades, global temperatures rise faster than any climate model has ever projected. The oceans begin warming at depth. Ice caps disappear within a generation. Coastal cities flood, not from melting ice, but from thermal expansion of the oceans themselves. Weather systems collapse. The water cycle, evaporation, cloud formation, rainfall, begins breaking down as the atmosphere saturates with water vapor. Rainfall becomes unpredictable, then rare, then stops. The Amazon, already stressed, dies within 50 years, not burned, not logged, simply cooked beyond the threshold where photosynthesis functions. Agriculture collapses within a generation, not because of war or mismanagement, because the temperature crosses the threshold where most crops simply cannot grow. Humanity doesn't end in an explosion. It ends in a slow, grinding inability to feed itself. Here's the moment of no return. Scientists call it the runaway greenhouse threshold. It's the point where water vapor feedback becomes self-sustaining, where no amount of human intervention, no technology, no geoengineering, no carbon capture can reverse what's happening. At Venus's distance, Earth crosses that threshold, not in millions of years, in thousands. The oceans, all 1.335 billion cubic kilometers of them, begin evaporating into the atmosphere, not all at once, but continuously. Relentlessly. As ocean levels drop, exposed seabed releases stored carbon dioxide, more greenhouse gas, more heat, more evaporation. The feedback loop that destroyed Venus runs again on Earth in fast forward. Within 100,000 years, the oceans are gone. Within a million, the atmosphere is unrecognizable. Carbon dioxide dominates. Atmospheric pressure at the surface climbs toward Venus's 90 atmospheres, the equivalent of being 900 meters underwater. The Earth doesn't become a dead rock, it becomes a second Venus, identical, indistinguishable, a monument to what happens when a planet sits just slightly too close to its star. Here's where the science gets genuinely strange. On Venus today, the surface is uninhabitable by any known life, But the upper atmosphere, at an altitude of 50 kilometers, is different. Temperature, 30 to 70 degrees Celsius. Survivable. Pressure, similar to Earth's surface. Breathable with the right equipment. Solar energy, abundant. Scientists have seriously proposed that microbial life could exist in Venus's upper cloud layers, floating in the atmosphere, never touching the lethal surface below. On Earth, at Venus's position, the same principle applies. As the surface becomes uninhabitable, the upper atmosphere remains a zone of relative survivability for longer than you'd expect. Not forever, not comfortably, but long enough that life, tenacious, adaptable, relentless life, might find a way to persist there. Not on the ground, in the clouds. Venus and Earth formed from the same material, at roughly the same time, from the same region of the same solar nebula. They are, in almost every physical sense, the same planet. The difference between them is 42 million kilometers. That's it. 42 million kilometers, the distance between a living world teeming with 8 billion people, forests, oceans, and music, and a dead, crushing, acid-soaked hell where lead melts on the ground. That distance is not a coincidence. It's not luck in the casual sense of the word. It is the single most precise and consequential measurement in the history of our existence. Every human being who ever lived, every civilization, every piece of art, every love story, every scientific discovery, all of it possible because of 42 million kilometers. Venus is visible in the sky tonight. You've probably seen it without knowing, the brightest object in the sky after the sun and moon. Beautiful from a distance, a point of light that ancient civilizations called the morning star, named after the goddess of love. But up close, it's the most hostile surface in the solar system. A warning, written in heat and acid and crushing pressure of what Earth could have been, of what Earth in a slightly different solar system would have been. So, the next time you feel rain on your face, or breathe cold morning air, or watch the ocean from ashore, remember, you're not just experiencing Earth, you're experiencing the 42 million kilometers that made all of this possible.